Alright, so we are continuing with solving systems. And yesterday we talked about graphing. So this will be two parts. We're going to do today solving with algebra, but specifically with substitution. The power of graphing it is you get to visually see what's going on. But graphing, especially if you do it by hand, is always an estimate. By doing either of the methods that we're going to do today or tomorrow, you get an exact answer. So there's also some power in that. But you don't see what's happening. So there could be some errors that we might find out. So here's my system. And it's already solved for y, so I could graph it. And the other power of an algebra is like it's easier to do like decimals and fractions and things like that than it would be to graph. Now I don't have any of that. And also a power of algebra over graphing is like, what if I had a really big y-intercept or a really small one? Well, then my graph might be enormous. So we don't want to limit ourselves. Now on the graphing calculator, we can quickly solve that problem. Alright, here's the concept of the substitution. Follow along as I do this. So I see y equals 4x minus 8 and y also equals 2x plus 10. So I see y equals two different things. So what I could do is I could say, well, y equals this stuff, so why not replace y in this original equation with that? So I'll say 2x plus 10 equals 4x minus 8. You see what I did there? I said, y is this stuff? So I just plugged it right in. And now I can solve it. So I'll build my wall. I'll subtract 2x. I'll add my 8. And then I divide by 2. And I get 9. Now I am not done. That's half the answer, right? I need an ordered pair. So I have only the x component of that ordered pair. I could take this and I back substitute it into one of these and it doesn't matter which one I do. So I'll try that one. So I'll say 2x. Y equals 2x plus 10. I now know what x is. X is 9. So y equals 18 plus 10. Y equals 28. So my answer is, that's the other half of the answer, my final answer is 9/28. Yes. And that's how I want you to do it. I want you to box each half step and then full box the final answer. That way it's easier to read. Now what's the question?
Well, for the homework, are you going to have a student vote pairs like that?
Yes. This is how you write it. Okay, let's go on and do another one. And our variables don't necessarily have to be x's and y's. Alright, so there's my system. Notice, this one's already solved for which variable? X. So wouldn't it make sense, do it the fastest way, wouldn't it make sense to take this stuff and put it in for x down here? So that's what I'll do. I'll do 4y plus 10. Now substitute into parentheses. I replace x with which quantity?
38y
minus 27, and that equals 120. Now I will have to distribute that 10, so I go ahead and do that. I can combine my like terms, so I get 34y. Also get your calculators handy, so that we can roll right through this. I add the 270. And then I divide by and get
11.47.
So it looks like I can just reduce this. So what's 390 divided by 2? I need you to speak up because of the construction. So it's 390 divided by, I'm reducing this fraction as opposed to using a decimal. So I divided top and bottom by 2, so what's 390 divided by 2 once?
195.
Thank you. I do need you to speak up because I'm deaf and plus it's loud outside. Alright, so I have a fraction. It is nasty, but ultimately that is possible that happens. I take that and I'm going to replace y with it. So it's going to make sense to replace it into this one that's already solved for x because that's the other thing I need to know. So I'll do x and then 3 times 195 over 17 minus 27. And it is going to be pretty nasty. So I need to multiply 195 by 3 because my denominator of that is a 1. So it's 195 times 3.
585.
Now I'm going to need a common denominator. The denominator of this is a 1. It needs to be a 17. So I need to multiply top and bottom by 17 in order to get a common denominator. So what's 27 times 17?
459.
459? I'm trusting you. I don't know. Alright, so now I subtract those. So I have my common denominator. What's 585 minus 459? Okay, so we do see a weakness here of substitution method is you might get, now it doesn't matter which method you use, you would get the same answer. Graphing could not get you it this accurate. But a substitution method, you do end up with fractions an awful lot early in the process. So the other method that we'll learn tomorrow helps us with dealing with fractions a little bit easier. Let's do another. We're just going to do a bunch of these. Give me a moment to finish copying that. Okay, I'll go on to the next. Sometimes you will want to change some things. But you have to make sure it's mathematically correct. So we could solve this exactly the way that we've been doing as far as substitution. But notice something about each of these. They are all divisible by what? 3. So I'll go ahead and do that just to make it a little bit easier. Okay, now I see this one. See this second one. Substitution you're going to want to use when something's already solved. And this one's already solved for y, so I take all this stuff and put it in for y in the other equation.
So you don't even have to put like a 3 on the outside that you took out?
No, I just divided everything by 3.
Yeah, you don't need to like put it...
No.
Okay.
Well, it would look like this. I did
Yeah.
times the third, right? And then it cancels everything. Okay, so we're putting in that y quantity. It just helps us out to not have something so complicated. Or let me put it this way. If we don't do that, we get larger numbers, which isn't bad. Now here, I can't do that. I couldn't divide those by 2 because, well, then this y would have a divide 2 on it. It wouldn't cancel, so I don't want to do that. So I distribute that negative 2. I'll get a positive 12x, and then a minus 68 equals 10. I'll combine my like terms, so I get 13. I'll add the 68, so I get 78 on the right. And what's 78 divided by 13?
6.
Now, what do we do with that 6? Well, I'm going to put it into here, right? So this is half the answer. So y equals negative 6 times 6 plus 34, which is negative 36 plus 34, which is negative 2. So what's my final answer? Well, make sure it's x comma y. X values first. Alphabetical order. If I had A's and B's, A first, then B. Does that make sense? Alright, so 6, negative 2. Final answer. Now, if I wanted to check this, what would I do? I'd plug it in and check and make sure that the given answer is correct. Let's do one more of these, and then we'll do one like that where we need to check and make sure the answer is correct.
Will you ever get a time where you'll get the bottom numbers, but it doesn't come into the other ones?
Yes, and then it's not a solution.
Okay.
Alright, so in this case, actually we'll probably do one more after this. I don't have anything already solved for. So then I select one. So I'm going to actually select this first one. So I'll bring over here x plus y equals 0. And I'm going to solve for, it doesn't matter which variable I select, I'll just select x. So I'll subtract y to the other side. And I get x equals negative y. Now I'm going to take that and put it into this other one. Right here. So I get 5 times negative y plus 2y equals negative 3. Distribute that 5. Combine those. And then divide by negative 3. And I get 1. Now I'll take that 1, see what we're doing. We put it back in here and we get x equals negative 1. So what's our final answer? Negative 1, 1.
So you can plug it into the equation you changed? Like you don't have to plug it back into the original?
Yeah, we can shortcut it as long as we didn't make a mathematical mistake here, that's fine. Because I want to get x as fast as I can. So, yeah, I could put it back here. I just don't want to, because ultimately I would end up subtracting that y anyway. So, yeah. Short answer, yes. All right. One more of these. I'm going to choose an equation to work with at first. Which one do you want? I would say the second one. And the reason I say the second one is it's the easiest to work with. If I choose the top one, I'm going to end up with fractions earlier. I want to avoid, it's not wrong, but I want to avoid that if I can. And which variable would you solve for?
What?
Yes, because it's just the easiest to solve for. So I subtract 2x, and y equals negative 2x plus 9. Now I'm going to take all of that and put it where?
Or back to y on top.
Yep, I put in y into the top one. Okay, so I get 7x minus 8 times negative 2x plus 9 equals 112. If I put it into the bottom one, I'm just going to get an infinite answer. You know, it's just not going to be helpful at all. So I get 7x plus 16x minus 72, and you have to be very careful with your math here because there's lots of different types of errors that you can make, so just take your time on it. I can add my 72, and I get 23x equals 184, I think. Divide by 23, and what do we get?
8.
Say?
8.
8. Okay, that's half my answer. I'll take that 8 back up into here, and I get y equals negative 2 times 8 plus 9. This equals negative 16 plus 9, which is negative 7. So, my final answer, 8, negative 7. And remember, alphabetical order. If I had C and D, then C, then D. If I had F and E,
One more time to plug this.
if I had F and E would go first, E, F. Alright, so this is my final answer, so I box it. Alright, let's do one where I give you the answer and see if you have to check to see if that actually is an answer. Okay? So, here's my system. Let's see here. Let's do -1. And -5. Is that a solution? So how do we check to see if that is indeed a solution? Yeah, I plug it in, but I need to check both. Alright, so I get -1 minus 3 times -5 equals 14. Follow the order of operations, I get -1 plus 15 is 14. And 14 equals 14, so that works in the first one. The second one, I get -1 plus 2 times -5 equals 8. -1 minus 10 is 8. -11 does not equal 8, so nope. So is this a solution? No. It has to work in both of them.
Do I have your permission in 7th and 8th hour to get your help with math?
Yes.
Okay.
Any questions on the substitution method?
So you put both the numbers in for both variables at the same time, right?
Yeah. Yeah.
And just make sure it works for both
It
problems.
has to work for both and when I say both, I mean all the equations that are in question. Because we're about to get to, well, what if you have 3 variables? What if you have 4? So this is pretty much so far a rehash of what you did in algebra. Anyways, here, let's see how good you are. So let's say this is our system. And then we'll go to whiteboards and markers. So put this in your notes, solve it. And I will have to end our recording here shortly. I'm going to put the answer up. That way you know if you got it right. This is the answer in the end.